Okay, so this is homework help week number 3, but this is for, the only questions I had were number 2 homework questions, and we're looking at number 6 and number 12. All right, so from homework number 2. All right, so my number 6 says, all right, the average amount of money that people spend at Don Mickles fast food is $7.29, with a standard deviation of $1.50. 12 customers are randomly selected. Please answer the following questions. First, what is the distribution? Well, this is normally distributed. It says it in the problem. So this is normal with a mean of 729 and a standard deviation of 1.5. And then it says, what would be the distribution of these 12 people? Well, we know from the central limit theorem, the mean would stay the same, but the standard deviation would be 1.5 divided by the square root of 12. So if I were to calculate that, it would be a normal distribution. On my calculator, I just take 1.5 divided by the square root of 12, and I would get 0.433. Right. Now, what is the distribution of the sum? Well, interestingly enough, you get the sum. What would be the sum of all 12? Well, each one averages this. So if I take 12 times each average, that would be the sum of all 12 of them, which would be 87.48. And what would be the distribution of the 12 of them again? If you take that average, the distribution, sorry, it's not speaking very well. This standard deviation, and again, times it by 12, you would get the sum of those. So to get the sum, all you do is you take the central limit theorem ones and multiply each one of those by 12. And then you get your 2 answers there. Right. Find the probability that one randomly selected customer spends more than $7.1905. So this is normal CDF on my calculator. Okay. This is my lower limit. More than upper limit, I put a really big fat number in. My mean is 720, and it's just a particular my standard customer, so my standard deviation is 1.5. That gives me that answer. Now they want to know what's the probability that all 12 of them average more than that. So I go to normal CDF again. I put this answer in again that they gave me, one really, really big number for my upper limit. Modeling infinity, same average, but now my standard deviation changes to 0.433. Hit enter and get that answer. Right? Probability randomly selected 12 customers will spend more total sum more than this. So I go to normal CDF, and I say, well, if they sum more than this, I put this down. And more than that, still a big number over here because we're going to infinity, modeling infinity. Our mean now is the mean we used for the sum, so this is 87.48. And our standard deviation now is the standard deviation we used for the sum, so $5.196. I hit enter and I get an answer for that. For part E and F, is the assumption of normality necessary? And the answer there that you want to put is yes, it is. Because our sample size is still really small, and it would be skewed if we only had 12 people. If we had 100 people, it wouldn't be so necessary. But with only 12, it's necessary. Central limits theorem says 30 is kind of rule of thumb cutoff, but the closer you can get to big numbers, the better off you are. The owner of McDonald's gives a coupon for a free sundae to the 5% of 12 people who spend the most money. Right? So 5% of all groups of 12 people who spend the most money. Right, so we want this 5%, upper 5% of 12 people who spend the most money. The curve that I'm going to use is this 8748 because we're summing the most money. Standard deviation is this 5.196. And I want this upper 5%, so I'm going to go inverse normal. My area, I could put 0.05 here. My mean is this. My standard deviation is this. But then I need to tell upper, so I need to say right because I want the right 5%. Okay. If I didn't use right and I just used left, or if my calculator only told me left, or if I'm using Excel, then I'd put 5.95 because the upper 5% is the lower 95%. Same mean, same standard deviation, but now it's giving me the left tail. Okay? All right, so that is number 6. And number 13. All right, so this is using a discrete probability distribution, which we might or may not remember from last year. And then we're going to use it to kind of conduct some, to apply the central limit theorem for it. Okay, so we have a number of pets, and I have the probability of owning those pets. 0 pets, 0.0023, 1, 0.0332, 2, 0.7673, 0.4176, 4, 0.3702, right? And if the households are sampled forever, the number of pets expected in the long run, this would be our mean, sampling forever and ever and ever, and then calculating the mean. Remember, you calculated the expected value in Stats 243A. The way that you do that is you take 0 times 0.0023 plus 1 times 0.0332. So you multiply each of these numbers across and then add them together. And that will give you your expected value. So when you do that in this case, you should get 3.1202. Right? And then they said, what's the standard deviation? And I don't know if you guys remember how to calculate the standard deviation, but the easiest way to do it is to put this list 1 into your calculator, this list 2 into your calculator, and then choose, I'll just add those in real quick to mine. So I'm going to go stats, edit, clear off my list 1 and my list 2 by going up to L1 and L2 and hitting clear and hitting enter. And then hit 0, 1, 2, 3, 4. And then put in these percentages, 0.0023, 0.0332, 0.1767, 0.4176, and then 0.3702. Now I hit stats, go over to calculate, stat, calculate, number 1 variable stats. My list is in list 1, and my frequency is in list 2. So I choose list 1, then I choose list 2, and then I hit calculate. Okay, and just like it's supposed to, my mean comes up as 3.1202, and my standard deviation comes up as 0.828222. Right? All right. A random sample of 49 is drawn from the sample. Can we say that the distribution of the averages of a size of 49 is normal? And we can say, yes, they are normal, but only because the sample size of the sample means is large. All right, so we can say that. Okay. Only because it's bigger than 30. That's kind of our rule of thumb, like I said. What would be the mean for the sample means? Well, the mean for the sample means would be the same as our other mean. So this would be the mean for the sample mean. So the mean of the x bars is 3.1202. What would be the standard deviation for the sample means? And that would be 0.828222 divided by the square root of 49, which is also divided by 7. So if I take that in my home screen on my calculator, 0.828222 divided by 7, my new sample standard deviation for the sampling distribution would be this, right? And that is question number 13. Thanks for the questions on the central limit theorem. Please let me know if you have any other questions on homework 3 or homework 2 or any of the homeworks. I accidentally did the wrong homework 2 assignment from last year when we were using a different book, so we're in a slightly different spot, but it is a really helpful video that I accidentally made for homework 3 and for showing how to find minimal sample size, and I am going to post that as well. Thanks a lot and have a great day.